All right, next set of notes. Ionic bonds. We're going to talk about bonding. So in an ionic bond, atoms tend to lose or gain electrons in order to reach a stable outer shell. And a stable outer shell is considered either at 2 electrons, as I said with helium, or at 8 electrons for all other atoms. An ion is an atom that has gained or lost 1 or more electrons and therefore is a charged particle. The negative charged equals gained and a positive charge equals lost. So if you gain an electron, you're going to be a negatively charged atom. If you are losing an electron, you're losing negative, so you're going to be a positively charged atom. So if you look at this diagram, you have sodium here, and it has one alone atom in its outer shell. And it doesn't like that. It doesn't like to not have a full outer shell. So what it's going to do is it's going to transfer that atom over to chlorine. So now if you look at this next one, sodium has lost its outer shell, so it's got a positive 1 charge because it gave 1 negative away. And chlorine, which had 7, now has 8 electrons in its outer shell, so it's got a full outer shell as well. So you've got a positive 1 and a negative 1, and so they are attracted to each other and they're held together to make sodium chloride, which is table salt. In covalent bonds, 2 or more atoms share electrons instead of gaining or losing them. Covalent molecules are often shown by a structural formula instead of a molecular formula. So up above, when it was NH2, CH2, COOH, that was a molecular formula, but a structural formula is down below. It shows how many bonds and what bonds where. So here you see that each oxygen has a double bond to the carbon, because carbon needs 4 bonds total, and it fills those by double bonding with oxygen. So each oxygen will share 2 electrons with the carbon, and carbon will share 2 electrons with each oxygen. Here, hydrogen is sharing 1 electron with oxygen, and oxygen will share 2 electrons, 1 to each hydrogen. And then here, nitrogen to nitrogen, nitrogen needs 3 electrons to be shared with it to be full, so each nitrogen shares 3 with itself. So above that it says structural equals chlorine bonded to chlorine, where the line represents a pair of shared electrons. So let's look at what those actually look like, and we're going to look at water, for example. So here, oxygen has 1, 2, 3, 4, 5, 6 electrons in its outer shell. Each hydrogen only has 1. So if hydrogen wants to be full and happy in its single shell, it's going to need a second electron, and oxygen needs 2 to make it happy. So here's your picture, oops, that didn't register that I was moving it, of water, where each hydrogen now has 2 in its outer shell, and oxygen has 8 total. Here's another example, nitrogen to nitrogen. Nitrogen only has 1, 2, 3, 4, 5. So in order to get up to 8, it needs 3. So each nitrogen will share 3 of its atoms, or its electrons. Notice there are 2 to this one that's not being shared and 2 to this one. Now, are the same electrons shared all the time? No, they'll kind of rotate in and out and switch around. But just for visualization purposes, they are sharing 5 electrons between them. Okay? I'm going to stop this recording and then start another one again with water, because water's a long section and I want to keep it together.